Hello Year 5 and welcome to your math lesson for today. So we're going to continue on with the lesson that we were looking at yesterday where we're adding fractions within one. So we're going to look at some more problem solving questions today in the hope that you'll be able to have a go at the worksheet if you manage to cope with the questions from yesterday. But before we do that, let's warm your brains up. So we're going to focus again on some of the multiplication division from our last unit. Set yourself a 5-minute timer and have a go at these questions. Off you go. Okay, write an equivalent fraction to a half. Now, we did this yesterday. If you look at your multiplication grid, any of those numbers that go from 1 to 12 and 2 to 24, those are all going to be your equivalent fractions. So it could be anything from 2 quarters, 3/6, all the way up to 10/20ths. Could even be 12/24ths, okay? Any of those would be equal to it. Multiply 168 by 5. It'll give you 840. Work out the perimeter of the rectangle. We know the perimeter is the distance all the way around the outside of our 2D shape. So if these are both 20 and these are both 6, you've got 40, add 12, and that's going to give you 52 millimeters. Now, write 500,000 in figures. Okay, so it's going to be 500,000. Okay, so well done if you got those right. Any mistakes that you've made, go back and just double check them. Make sure you've got the correct answer so that you know where you went wrong for next time. Now, if you had a go at doing the time, it is indeed 20 to 6, which means it's 40 minutes past 5. So it'll be 5:40. It's a 24-hour clock. It's going to be 17:40. So well done if you're able to get the time for that one as well. Right, let's warm your brains up for some fractions now. So this is going to be recapping the fractions work that we looked at yesterday, okay? So can you find the missing number for this fraction here? Remember, this is the equal symbol, so they've both got to be the same total on each side. Here, this looks like it's going to be an equivalent fraction, and the same goes for this one here as well, okay? So pause the video, set yourself a 5-minute timer, and have a go. Okay, so the first one here, we know if we added these together, it gives us 9/10. Okay, so between them here, this has also got to equal 9/10. We're going to have to convert that denominator there. So we've got to think, well, how do we get from 5 to 10 multiplied by 2? Which means our numerator here has got to also then be multiplied by 2. Okay, so the answer there would give us 6 because we need to get from 3 to 9, so that's going to be 6. So if we divided that, it would then be 3 because 3 multiplied by 2 would then give us the 6. Okay, a little bit backwards there, but I'm going to explain how that works in our lesson today. Now here, this is just an equivalent fraction, so we're looking for 2, because 6 goes into 24 4 times. So we need to think, well, what goes into 8 4 times? What 2 does? And the answer for this one here is 2/3, okay, because 6 and 9 can be divisible by 3. 6 divided by 3 twice, 9 divided by 3 goes 3 times, so it's 2/3. So well done if you got those correct. That first one we are going to explore a little bit more in today's lesson. So let's do an easy peasy one. 1/3 add 1/6. We can see we're going to use our bar models here, and we're going to separate them here into our strips. So we can see that the thirds have now been split into 6. We can see it's now 2/6 add 1/6, which is 3/6. Okay, if we move that one over. Now, if you notice here, we've got 3 shaded and 3 not shaded, which means 3/6 is also the same as a half. Okay, because 3 goes into 6 exactly 2 times. Okay. Easy peasy one so far. So now have a go and do this one on your own. Okay, well, if we block this one up on here, so they're now all in 12ths. We've got 3, 6, 9. Add another one. We've got 10 12ths all together here. Okay, because we had 9 add 1. Now, if we're thinking 10 12ths, well, we can think, well, how could we simplify that? Okay, so think, well, what goes into 10 and 2 that's the smallest possible number? Well, 2 does. So think, well, how many times does 2 go into 10? It goes 5 times. How many times does it go into 12? It goes 6 times. So it's going to be equal to 5/6. Don't worry if you didn't get the simplified version, as long as you got the main answer, then that's fine. So let's put it into a problem solving situation to help us. So Annie runs 7/20ths of a route, and Ron runs 2/5ths of the same route. So between them, how much of the route do they run all together? So have a think. What could I do to these two fractions that I might need to do, or what might I need to do to these two fractions to be able to work out my answer? There we go. Pause video and have a think. Okay, well, I can see my denominators are different, and because my numerator is different, I'm going to have to match my denominators. So I need to find the lowest common multiple, so a multiple that appears in the 20 times tables and the 5 times tables. Well, I know it's going to be 20. So you think, well, how do we get from 5 to 20? I've got to multiply it by 4. Okay, so whatever I do to the bottom, I also do to the top. So it's going to give me 8/20. All I need to do is then add them together. And that gives me 15 out of 20. Now, can I see any other common numbers that I think that I could match from that one as well? Well, yes, I can get 5s because 5 goes into 15 and 5 goes into 20. So 5 goes into 15 3 times and it goes into 20 4 times, which means that that is equivalent to 3/4. So between them, they run 3/4 of that entire root together. Okay? So now that we've whizzed through that, because that should be fairly simple to grasp from the work you did yesterday, I'd like to have a go doing questions 1 to 3 on your worksheets. And then we're going to come back and we're going to make it slightly more complicated. Okay, so here we have some missing numbers. Okay, now you might notice that the denominators are different. Okay, and the answer is in ninths, which means I need to match all of my denominators. Now, the lowest common multiple for 3 in the 9 times tables is 9. Okay, so I can change my denominators. Now, this looks like I can put any numbers in here. Any multiples of 2 numbers that add up to 7 surely can go into those 2 boxes. Or can they? Well, let's have a look and think about it. So let's add 5 and 2. I know that 5 and 2 equals 7. So if I was just looking at this section of fractions here, then yeah, my answer is absolutely correct. But I need to think, well, actually, whatever I've done here, I've multiplied to get to 5/9. So I then have to be able to think, well, what happens if I do it backwards? Okay, so what could possibly be wrong with my answer? Pause the video and have a think. Okay, so if I've multiplied these numbers, I've got to then divide it, okay? So if I divide it, I know I've had to divide it by 3 because I've multiplied it by 3. But I can't do 5 divided by 3. That's going to give me an odd number, okay? That's going to give me a decimal, and I can't have a decimal within my fraction. So we can't have the 5 and the 2, okay? But we know because we've had to divide it by 3 and multiply it by 3, it's got to be a multiple of 3. So it can either be 3 or it can be 6, okay? It can't be 9, okay, because it would have then ended up being a much bigger fraction. And we can't have 9 wholes because otherwise if I had 9, that's already bigger than my 7. So it can't be any bigger. So then if I'm doing 3, well, 3 add 4 would give me 7. So I could have 4 there, or 6 and 1 would give me 7. So let's try it out with the 3 and 4. So if I had the 3 and I had 3/9 in here, well, I'm thinking, well, I've multiplied it to get from 3 here. So what would 3 divided by 3 be? Well, it would give us 1, which means my answer here would then have to be 4. Okay, because if I had 4 here and I added my 4/9 here, okay, it would have been my 6 add my 3 add my 4, which would have given me 7. Okay, equally, if I had it so that this was 6 and 1, I think, well, how do I get from 6 to 3? Okay, and I've divided it by 3. It's going to give me 2. Okay, and then this number here would have then just been my 1, because it would have been 6 and 1, which would have given me 7. Okay, so you have to think about the inverse and flip it backwards. Okay, and that might seem a little bit confusing because the numbers aren't in there, but if you imagine them as the pairings and you did them in there, you don't have to work out the numbers backwards. Okay. Now, I wonder if any of you have ever come across this before. So this is an addition pyramid, okay, and you might not know how it works, so let me show you. So if I had the numbers 3 and 5 here, these two numbers are an addition sum, and these two numbers together will give me the answer in this box, okay? So if I did 3 add 5, 3 add 5 would be 8. 5 add whatever this number would be, would then give me the missing box here, and then these two numbers added together will give me this one up here. So the two corresponding boxes total the answer to the number that's above it, okay? So let's do it so we're looking at fractions. Now, I'm looking at this and I need to think to myself, well, what do I know that's similar? Okay, what can I change with these fractions to help me? Okay, and I can see here that I could change all my denominators so that they're all multiples of 20. Okay, so let's then convert them. So if I think, well, how do we get from 5 to 20? I multiply by 4, so 1 multiplied by 4 is 4. 10 to 20 is multiplied by 2, so I times 2 by 3, and that gives me 6. So now all of my denominators match on my 20. So if I now did 4 add 6, 4 add 6 is going to give me 10 over 20, okay? Now I need to work out what that missing box there is. So what I want to do is pause the video and have a think. Can you work out the missing answer of this box, and then the two answers that make this answer at the top? Pause the video and have a go. Okay. So here I would have 6 and 3. So 6 and 3 is going to give me 9 over 20. And if I add my 10 and my 9 together, that's going to give me 19 out of 20. Now, I wonder if you've noticed if there's one fraction in there that I could actually change and simplify it. Wonder if you've picked it out? Yeah, good. I can actually change my 10 over 20 for a half. okay, because 10 is half of 20. So I can exchange that one there for a half. Now, looking at that, if you covered up these numbers, you've got fractions here with multiple different bottom numbers. But because you've worked out the equivalent fractions here, and you've exchanged them over into different numbers so that your denominators match, you've been able to work out that entire pyramid on your own. Okay, well done. So now that you've had a go at doing that one, see if you can have a go at doing questions 4 to 7 on your worksheets. There is no additional challenge question for today, purely because I don't want to confuse you with the last few questions, but we will be moving on to looking at our next part of our topic, which will be looking at adding 3 or more fractions. So I might start throwing in some more challenging questions then, okay? So good luck, year 5.